students. Welcome to the e-learning session, an initiative started by LJ Institute of Pharmacy. I am Dr. Jignesha, working as professor in the Department of Quality Assurance at LJ Institute of Pharmacy. In today's class, we will be going through the practical session of fluorescence spectroscopy. In contrast to absorption spectroscopy, such as UV visible spectroscopy, fluorescence spectroscopy involves emission of the radiation. In case of UV spectroscopy, we determine the amount of radiation that is being absorbed by the sample, whereas in case of fluorescence spectroscopy, we determine the amount of the radiation which is being emitted by the sample. Molecules in which the electrons are present in the outermost orbital, which are not involved with the bond formation, when they are exposed to shorter wavelength of the radiation, then the electrons will absorb the radiation, and after that they will undergo transition from singlet ground state to singlet excited state. This singlet excited state being unstable, associated with higher energy, the electrons will soon undergo transition to the ground state, that is singlet ground state, where the electrons will be in the unpaired condition. By transition of the electrons from singlet excited state to the singlet ground state, these electrons will emit photons. The energy of the photon depends upon the excitation wavelength and the emission wavelength of the radiations. Now, while returning back to the ground state, when these photons are emitted, this photon's intensity, it is measured. The quantum of the energy which is being absorbed by the sample, it depends upon the extent of unsaturation which is present in the compound. So this is how, by determining the intensity of the radiation emitted depending upon the Beers and Lambert's law, we determine the concentration of the sample.
Myself, Darshil Shah, working as assistant professor to Department of Quality Assurance at LJ Institute of Pharmacy. Next, we will discuss the operation of the fluorimeter. Going towards the operation, first we will discuss the various instrumentation part of fluorimeter. The fluorimeter consists of first light source like mercury vapor lamp, second filter, that is a primary filter, third one is a sample holder which holds the sample, fourth one is the secondary filter, and fifth one is the detector. As you can see that the two filters are used in case of fluorimeter. So the primary filter generally filters the UV light and generally it is used for the excitation wavelength, while the secondary filter is used to filter the emitted wavelength, while the detector measures the emitted wavelength. We are going to measure the concentration of quinine sulfate by using fluorimeter. We are having a fluorimeter CL53 by company Alico. First, switch on the mercury vapor lamp, then switch on the detector, then place the filters as required. Here you can see that the secondary filter is adjusted onto the 90-degree angle because it only measures the